Alright class, welcome to lesson 6, Heron's theorem. I have to teach a class upstairs and teaching general science right now while you watch this. So I'm going to do this lesson remotely, I guess you could say. This lesson, Heron's theorem, it's a theorem so that you can find the area of a triangle. Like here's the Bermuda Triangle. If you want to read the story, it's in the book. It's a triangle between Florida, Bermuda, and Puerto Rico. And that's where things disappear. Do you ever hear about that? Well, we can find, without the altitude, it would be hard to find the exact altitude of that Bermuda Triangle, but they can find the distance of the sides. So someone came up with a formula. Actually, his name was Heron, and another guy, Heron of Alexandria, and another guy, Archimedes, actually discovered it, but Heron's proof lives on, and you can see it in the book. It's about 2 pages proving the theorem that he's going to do. So we're going to use, in order to use Heron's theorem, we have to know a definition. So here's the definition. The semi-perimeter of a triangle is the number that is half its perimeter. So that's easy enough, right? So here's a triangle. The semi-perimeter would just be all the sides, A plus B plus C. And it's a semi-perimeter, so it's divided by 2. So that's the semi-perimeter. Using the semi-perimeter, we can plug it into what's called Heron's theorem. Heron's theorem says the area of a triangle with sides of length A, B, and C and a semi-perimeter F is. So right here, this blue, what I circled, is Heron's theorem. What it says is semi-perimeter times the semi-perimeter minus side 1, semi-perimeter minus side 2, semi-perimeter minus side 3, all multiplied together, and then you take the square root, and you can find the area of any triangle. So keep that in mind. And there's one last theorem in this section, and then we'll do a couple examples. This is actually a corollary. The area of an equilateral triangle. So here's where it's a little bit different. If you had an equilateral triangle, you can find the area of it with just one side. It's area squared divided by 4 times the square root of 3. So let's just do a couple examples, and then I'm going to set you guys loose in your groups like what we've done in the past. Get with a couple other people. Don't work alone. Get a friend to work with to help you through some of these, and we'll do the first 15 problems. So let's start out with, let's see, what did I have here? Let's just do a really simple one. Let's just do a 3, 4, 5 triangle. So I'm going to draw a triangle, and we're just going to pretend, I'm just going to draw this. This is really bad. We're going to call this one 3, this one 4, and this one 5. This particular one's a right triangle, so I'm going to show you how it works the same both ways. If we're going to do it the old way, this is the altitude, so we would find the area of a triangle equals 1/2 base times height. And so when we do that, we would get the area of this triangle equals 6. Now I'm going to show you how Heron's theorem will give you the same answer. Of course, when you have an altitude, it's a lot easier just to do 1/2 base times height. But if you don't have the altitude, then you can't use the altitude. So this Heron's theorem is, first we're going to find the semi-perimeter. So we're going to add up all the sides. 3 plus 4 plus 5 divided by 2. So when we do that, we get 6. That'd be 7 plus 5 divided by 2 is 6. So the semi-perimeter is 6, and then we put it into the Heron's formula. So you would take 6, that's your S, and then it's going to be the semi-perimeter minus side 1, I don't know why I keep saying that, semi-perimeter minus side 2, and the semi-perimeter minus side 3. So we're going to get the square root of 6 times 3 times 2 times 1. And that will give us a square root of 36, and it gives us 6. So that's how you use Heron's theorem. Let's apply the corollary that's right up here. This time, this is number 15 in your book. So I guess you don't have to do up to 15 because I'm doing 15. Here's an equilateral triangle. That's a very bad equilateral triangle. Let's get a nice, pretty equilateral triangle. That's kind of equilateral. It's better than what I drew anyway. Okay, this one, we have one side is the square root of 20. We can find the area of an equilateral triangle by just putting it into this formula right here. So we have the square root of 20. That's my dog eating very noisily. Squared. So that's your side. Divided by 4 times the square root of 3. And that's going to give us the square root of 20 squared is just 20 divided by 4 times the square root of 3. And that's 5 square root of 3. So the area of this triangle is 5 square root of 3 using our corollary. So that's just if you have all the sides are the same, you can just plug it right in here. You don't need to have the altitude. So you don't need to have that altitude. Let's try a couple more. I need to erase all this, so bear with me. Alright. I'm having trouble getting my erasing to work. Let's just take this all out. Okay. Let's try number 23 in your book. Number 23. This one says, the right chapter. This one says an isosceles triangle, 2 of whose sides are 4 and 10. So we're going to find the area of isosceles triangle. The sides are 4 and 10. So you're going to have an isosceles triangle. Let me draw an isosceles triangle. And the sides are 4 and 10. So you have to decide. You don't know which ones are 4 and which ones are 10. But if you think about it, if you have 2 4 sides, they're not going to add up to greater than 10. So the sides will collapse. So if you had like a 10 and then 2 4s, the whole thing collapses. So because of that, we can easily say this is 4, this is 10, and this is 10. We're going to find the area of that, and we're going to use Heron's theorem because we don't have an altitude, so we have to use it. So the first thing you do is you find the semi-perimeter. You add up the sides, 10 plus 4, divided by 2. So you get 24 divided by 2, and you get your semi-perimeter is 12. Then you put it in Heron's theorem. Let me write here on Heron's theorem since I don't have it up here anymore. Heron's theorem says S, which is semi-perimeter times semi-perimeter minus A, semi-perimeter minus B, and the semi-perimeter minus C. So here we go. So it's going to be the square root of 12, 12 minus 10, 12 minus 10, and 12 minus 4, which is the square root of 12 times 2 times 2 times 8, and that gives us, it's going to end up being 8 square root of 6. So you are going to have to deal with some square roots under here. I think the way that I did it was I just went 2 times 12 is 2 times 2 times 3 times this 2 times this 2, and then 8 is 2 times 2 times 2. And then I found the pairs. 2, 2, 2. So that would be 2 times 2 times 2 is 8, and then I'm left with 6 under the radical. Alright, one more problem and we'll be done. I know it's probably torturing you guys watching such a long video. Alright, 32. This one is kind of a crazy picture. Let's see if I can use my triangle thing to help me. My triangle tool. Okay, here we go. here is the triangle, and it also has a part that comes down like this. And you are supposed to find this area in the middle. I don't know if this is going to work, but I'm going to try something. So yeah, we're supposed to find the red area. They're going to give us our sides. We're given this is 8, this is 9, this is 8, this is 5. Whoops, can't use red on that. This is 5, and this is 5. So we're supposed to find the area of the red spot. So the first thing we're doing, we can find, this is a right angle too, we can find the area of the big triangle just using our normal formula. So the area of the big triangle would be 1/2 base times height, so it would be 17 times 8. And so that would come out to be 9. So you work that all through. Actually, it's not 9. It comes out to be, that's the semi-perimeter is 9, 68. So this comes out to be 68. So that's the big triangle. Now we have to subtract from the big triangle this this area right here. But we don't have the altitude of this area. So in order to find the area of this little triangle, we have to use our Heron's theorem. So we have to find the semi-perimeter, which would be 5 plus 5 plus 8 divided by 2. So that would give us what I initially said was 9. Then we put that into the formula, and we're going to get the square root of 9, and then it's going to be 9 minus 8, 9 minus 5, and 9 minus 5. And when you work that all through, you're going to get 12 when we finish all that up. See, I need a little bit more space. So that equals 12. So what we're going to get is 68 minus 12. And that's going to give us, if you work all this out, you're going to get 144. Square root of 144 is 12. So we're going to get 56. So the area of this little spot right here is 56. So Heron's theorem is pretty easy to work with. So I think once you can plug in the formula, I think it's a pretty cool thing that you can find the area of a triangle without the altitude. So for the rest of the class, here's what I want you to do. Hold on a second. Still a rookie with this stuff over here. The rest of the class, this is what I want you to do. And I probably can't get it to get bigger. Cover all this. Maybe I can't do anything. The rest of the class, do lesson number 6, 1 through 20 in your small groups. I guess I meant 1 through 20. Help one another out. Try it first without using the answers. Don't be dependent on the answers. Try it, and if you can't get it, then look at the answers. Then after that, stay in your small groups and do the chapter 9 review exercises. And I gave you the answers for those too. And then if you had any questions on your homework that we couldn't answer in class today, I put a sheet of paper in the front of the class with each lesson on it. If you could just write the numbers that you didn't get on that sheet of paper, I'll get back to you this week and answer those questions for you. The homework this week is tomorrow you need to finish this lesson, lesson number 6. Monday, do the practice tests that I handed out. The answers are, I'll have the answers on the website. Tuesday, take the test, and then Wednesday we're going to start chapter 10, and I'll have a video. It's pretty easy though. So hopefully you got everything in the lesson and can do those problems together. I might come down at the end of class to see how you did. I shouldn't be teaching the whole time. So have fun.